So let's try to look at the question on application of integral calculus. So the question is asking us to say find the length of the arc, or in short the arc length, if you are given the function y is equals to x to the power 2 over 3, and you are given the interval 1 to 8, of which it can also be written as that 1 to 8, like that. That's the interval that we are given. So we need to find the length of the arc at this given interval of this equation that you have. All right. So before I go straight forward into just, or let me say, I'll not really go straight forward into solving this question as in just determining the arc length, then it ends there. I'll try to explain briefly what we mean when you're talking about determining the arc length. Okay, so what it is that, of course, we are well aware that determining the arc length is just more like what we are doing is just application of integral calculus. So it's more like um, the same we have been talking about when it comes to the area under the curve. So it's more like, let's say you have this as our axis, that's our y-axis, and that's our x-axis. Then let's say if you're given a curve of this kind, you can determine the area under this curve by means of integral calculus, where you have the lower limit here and the upper limit, which I'll just indicate as n there. Okay, so now let's talk about a situation whereby you have something like let's say we have something of this kind. Okay, so let's say this is our f of x. In this case, this is our function. How can I determine the arc length of this curve at a given portion? Okay, so at the given portion, what I mean is that I can separate it. I can say, okay, at this point, let me say this is a. Okay, then at this point, uh, let me say this is what, let me say this is b here. Okay, so I want to determine the length of this arc at, like, at that point. That's what I want to try to find, but I want to try to use integral calculus. How am I going to do this? Okay, so what we are going to do here is that I'm going to pick the smallest possible portion of this same arc. Let's say I pick something at this point as well as at that point. So writing this in terms of I can write this way. Okay, I can write it this way. So this is a situation whereby if this is as small as possible, we can try to think of it in terms of Pythagoras theorem, whereby we can take this as if it's a straight line. What I mean is that if it's very small, of course it appears to be bigger here, but imagine it's very small. Okay, such that if the length of this arc is L, okay, then here I'm going to indicate it as DL. Okay, then at this point, this I'm going to indicate this as my dy, meaning change in y. This is going to be my change in x, which is dx. Okay, so by Pythagoras theorem, we know that our dl is going to be equals to the square root of um, dx squared plus dy squared. Okay, that is by Pythagoras theorem. Okay, so what it is here is that when it comes to finding the gradient, we know that the gradient of a function, which is simply a which comes from the gradient function of that particular function, is written as f prime of x, like that, which in this case is going to be equals to dy dx. Okay, which is going to be equals to dy dx. So there are several ways of coming up with the formula that we're going to be using for determining the arc length. You can use some manipulation to come up with that, and you can use some other method. You're still going to come up with the same equation at the end, of which I can just try to write it here so that we have a picture of what we are looking for. So our arc length, which I indicate as L, is going to be equal to the integral of uh, let me say you have the limits there, a b, then that will be the square root of 1 plus um, f prime of x or simply dy dx squared, okay, dx, like that. So let's continue now. We want to try to arrive at this destination. Let's try to continue and see what we're going to be getting. So now, what it is that at this point, this that I have as my DL, I have to integrate it both sides. Okay, so integrate both sides of this. That's just going to give me what? This is going to give me L is going to be equals to the integral of this that I have here. But keep in mind that, or maybe before I do that, maybe before I do that, before I go as far as this, I'll leave it this way. Okay, I'll leave it that way. So I'm going to say my DL is going to be equals to. So what I'm going to do here is that what I have inside the brackets there, I'm going to, it's like I'm not really calling it factoring, but I'm just going to force the dx squared outside. Like it's going to be something like dx outside. It's like I force it out. I don't change the meaning, but I just perform some manipulation. So this is just going to be plus uh, dy. So I'll divide by dx, then I'll say squared, like that, so that I don't change the meaning. Okay, so meaning this is going to be dl is going to be equals to, I'm going to have dx outside. Okay, I'm going to have dx outside, then here I'm going to have 1 plus dy dx squared. Okay, I can write this as dl is equals to the square root of 1 plus dy dx. But remember, my dy dx is nothing but the gradient function, which you can write as y prime, I mean f prime of x. This is going to be f prime of x squared, and I have my dx. I'll put it at this point. So now where I've reached now, I can integrate both sides of what I have. Okay, so this is just going to give me L is going to be equals to the integral of, and I'm going to give myself intervals. Okay, starting from the high, like I have the lowest interval A and my highest interval B, and that will be what? Square root of 1 plus f prime of x squared dx there. And this is the formula for the arc length. That's how it comes about. Of course, you might find how they derive it using some kind of like some infinite sum methods, so you have to know what your lower limit is, your upper limit is in terms of the infinite sum. It's still one and the same thing. You still arrive at the same conclusion, which is going to be that. And that's what we have. So now let's try to use this to determine the arc length of that given function. And we already given the interval. Okay, so we are told that the L, which is what you're looking for, it's from 1 to 8. Okay, so that would be the integral of 1 plus. So I have to differentiate this. So my y is equals to x to the power 2 over 3. So my y prime, which is my f prime of x, just going to be 2 over 3. Then x, I have like 2 over 3 minus 1, which is just going to be, we are saying 2 minus 3 divided by 3, giving us negative 1 over 3. So my y prime is going to be equals to 2 over 3 x to the power 1 over 3. That's what we have right there. So we have 2 over 3 x to the power 1 over 3, and this is squared, then we have dx there. So I have like my L is going to be equals to integral of that, we have that limit there. So this is going to be 1 plus 4 over 9x to the power 2 over 3 dx. Okay, So now it's just a matter of following it step by step, and it's very very interesting. So here I'm going to make this like I'm going to, it's not like I have a 1 here. I'm just going to make it as like I'm going to write it as a single fraction. Okay, so I'll multiply the 1 by the 9x to the power 2 over 3 plus 4, then divide both side, divide everything by 9x to the power uh, 2 over 3, then you have dx there. So what you observe is that this can be written as L is equals to, you have your 8 1 here. Okay, so on the numerator I'll write it as a separate root compared to the denominator. I'll have like 9x to the power 2 over 3 plus 4 divided by the square root of 9x to the power 2 over 3 here, and we have dx there. Okay, so this is simply L is equals to our 8 over 1. Okay, so we have like the square root of 9x to the power 2 over 3 plus 4. Okay, so here I'm going to have 3, then I'm going to have x to the power 1 over 3, like that, dx. How does this come about? What I have here is more like you have your square root of 9 multiplied by the square root of x to the power 2 over 3. The square root of 9 is simply a 3 multiplied by the square root of that is can be written as x to the power 2 over 3. You close, then that is 1 over 2. This goes and that goes, remain with 1 over 3. That's how I ended up with that one. So now you observe to say I can bring the 3 outside. That's going to be 1 over 3, then that will be like 8 there, 1. So that's going to be 9x to the power 3 over 2 over 3 plus 4 divide by x to the power 1 over 3 dx. So now, looking at what I have, I believe I'm able to use u substitution to integrate that. So what it means is that I'm going to let my u, okay, I'll let my u be equals to 9x to the power 2 over 3 plus 4. So meaning my du is going to be equals to something like I think it's going to be 6. Okay, 6x to the power that would be negative 1 over 3. Okay, let's write it anyway. So this is going to be like 2 over 3 multiplied by 9x 9x to the power 2 over 3 minus 1 dx. Okay, so meaning our du is equals to 3 there, 1, 3 there, 3, 3 by 2, 6. That would be x. So this is simply 2 minus 3 divided by 3, giving us negative 1 over 3. So we have negative 1 over 3 dx there. So having said that, this is simply du is equals to 6 over x to the power 1 over 3 dx. So meaning our dx is now equals to du, or before I say that, we are doing the cross multiplication here. That would be like x to the power 1 over 3 du divided by what? Divided by this 6 here. So I had to make this one a positive, the power a positive, by bringing it down here. Alright, so here I can come and say this dx can go. I'm just going to substitute here. That will be multiplied by, what's by dx? Dx is x to the power 1 over 3 du divide by 6. And once again, here I can erase what I have here and indicate it as u. Okay, and I'll not say square root of u, but I'll just write it as u to the power 1 over 2. So you observe to say at this point this is able to go and that is able to go. All right, so how is that then going to be? so we can erase that, but anyway, I can leave it at that point. I'll still need to get back to what my u is. So now I can say my L is equals to 1 over, so this is the 3 multiplied by the 6, that will give me 18. Okay, it will give me 18 there. So I have 18, that would be like 8 1, then u to the power 1 over 2 du. Okay, so now we can do the integration. Now this is going to be, L is going to be equals to 1 over 18. Okay, then integrating this, what do we get? We are saying u to the power 1 plus 1 over 2 plus 1 divided by 1 over 2 plus 1. This is simply like u to the power 3 over 2 divided by 3 over 2, of which we can just write it as 2 over can write it as 2 over 3 u to the power 3 over 2. Oh my god. Okay, so here we're going to have 8 and 1 there. So we observe to say, we can say 8 here 1, sorry, 2 here 1, 2 into 2 1, 2 into 2 1, 2 into 18 is 9. 9 times this 3 is going to give us 27, so we have like 1 over 27. Okay, I'm just confirm that 1 over 27. Okay, then we still have the u, which is u to the power 3 over 2. Then we have the boundaries from 1 to 8, but these are in terms of x. Okay, they're not in terms of u, so you have a choice to make here. It's either I find the boundaries that are in terms of u, okay, or write this as x. So I have my a is equals to what I have there, which is that. So I think the best thing I can do right now is do anything that I'm able to do. Yeah, there is no like limitation in terms of what you're able to do. Let me not take this back into what it was in terms of x. Let me write it in terms of u. So I'll say, okay, u is equals to, so now I'll say 9. I want to find what my u is when x is 8. So here where there's x, I'm going to put 8 to the power 2 over 3 plus 4. Okay, of which I believe that's going to be something like a 4, because the third root of 8 is a 2. 2 squared is a 2, so it's more like you're saying 8 to the power 1 point, is it 1 point? No, it is 2 divided by 3. Yeah, we get a 4 multiplied by 9, we get 16. No, why is my calculator giving me 16? That's wrong. Okay, um let me write it this way. Mm, 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 mm. Okay, so I'm saying u is equals to 9. Then this portion gives me a 4 plus a 4, like that. So what do we get there? So we have 9 multiplied by 4, 36 plus 4, giving me 40. So this is a 40. Then I want to find out what my u is when x is equals to 1. That one there that I have, or it's the same one. So that's going to be like 9 multiplied by 1 to the power 2 over 3 plus 4, which is same as 9 plus 4, which is 13. So now I'm going to say is y L is equals to 1 over 27 there. So that would be u to the power 3 over 2. The limits now change from 13. It will now be from 13 to what? 13 to 40. Okay, so our A is going to be equals to 1 over 27. So we are saying our u, we are going to say 40, okay, to the power 3 over 2 minus 13 to the power 3 over 2 there. Okay, which is pretty clear what we are going to get, because now it's just a matter of using the calculator, if you're allowed to use the calculator anyway. Okay, 1 over 27. Okay, so what I'm saying is that I'm saying 40 to the power 1 to the power 1.5. I'm going to get something like 252.98 minus, if I say 13 to the power 1.5, I'm going to get 46.87. So doing the subtraction there, the 252.98 minus 48.87, I get 1 over 27 multiplied by 204.11 or 11. So I divide by 27, I get a value of 7.55962,963. That's what I get. If you happen to get something different as you do the calculations, please leave it in the comment section. But otherwise, the format of coming up with this is correct, unless if I've just made a mistake on the computations. But otherwise, that's how we go about answering that question. If you enjoyed the video, don't forget to leave a like, and if there's anything that I've done that is contrary to what you believe should be done, leave it down in the comment section and we'll reason from there. Otherwise, thank you very much for the love and the support, and we'll see you in the next video. Thank you very much. And maybe before I go, this is the length. Length is measured in some units, can be meters, millimeters, or something. I'm just going to say units like that, and we can round this off. Area is going to be equals to 7.6, I mean 7.5, let me use two decimal places, 6 there, units. And there we have it. Thank you very much for watching once again.